Now the problem then is that if you stop there, did I make a mistake? Oh, sure would. There goes my error. Darn it. 40 meters per second, yes? Dang it. So then, when you read the question, like I did not do in the notes, it actually asks what's the speed in miles per hour. So now you have a whole lot of unit multiplier work to do to convert that to miles per hour. I first went meters to centimeters, and then centimeters to inches, and inches to feet, as you can all see. And that times 20 is, what the heck, I'm having a rough time here. Times 20. All right. Well, I had a 2 there, so I need to bring in a 20. So did you get something like 89.477? 89.477 miles per hour. You follow? Okay. Number 2, when you do distinguishable permutations, you take the total number of things to be arranged, which is 9, and divide out all the different ways to arrange the little subgroups because they're indistinguishable, therefore reducing the number, 1,216. You should be able to do that without a calculator. Are you good there? Okay. If it's, yeah, do mark it wrong if you used a calculator because it was not starred. You should have not used a calculator. Okay, number 3. The period of that was 4 pi, which means it was stretched a little bit. So now, instead of just x, you should have 1/2 x. So something like 4 cosine of 1/2 x plus 5. It did say write a cosine function, so if you use the sine function, it is wrong. It said in the question use cosine. All right, number 4. You can't find the area of that trapezoid until you know the height. So you should have used trig to find the height. The height was 6 sine 40 or 3.8567 if I can read my own writing. If you use that, then for the area, I have 42.4239 square kilometers. You good? Okay. 5, the central angle of a sector, the area of a sector. Area of a sector is a fraction of the area of a circle. In this case, then, the fraction you have is 3.4 out of 2 pi total radians. Answer 15.3 square centimeters. Number 6, pay attention to how this should be written. It says write 3,800 as 10 raised to a power. So your answer should be something like 10 to the 3.579 is the answer. If you just have 3.579, that doesn't answer the question. It says write it as 10 to a power. Same deal on B then. As e to a power, it's e to the 8.2427, not just 8.2427. You follow? Okay. They're each 1 point, sorry. So yes, 1 point each. Good call. Okay. For 7, I'll go with, did you complete the square correctly? Did you put the parabola in standard form correctly? Did you get a parabola shifted right 1, down 3? If you did not get that, then you completed the square badly. Do you want to review that, or are you doing okay there? What? Review. All right, so the original equation was y equals x squared minus 2x minus 2. And you have to graph that. It's not in the typical form, and I don't want to ask Matt or make a table, so you're going to put this in standard form. Standard form looks like this, and the big idea on standard form is there's a perfect square there. That's why we use completing the square. So first thing you're going to do is push the constant off to the side, leaving a space where we're going to put our own constant in to make a perfect square. In that space, then, the rule is half of this x coefficient squared. Half of 2 is 1, squared is 1. You can add 1 there as long as you balance the equation by either adding 1 to the other side or subtracting 1 from the same side. Do you agree that's balanced? Okay? The net result then is now this is factorable. With that 1 there, I could factor that. How does that factor? X minus 1, x minus 1. That's the whole point of what we added there, is to make it a perfect square. The constant stuff is minus 3. Then you can say, oh, I see. Now it's shifted right 1, down 3. So that's where my vertex is on my parabola, 1, negative 3. The parabola should open up because you have a positive x squared going on. And then the line, you should be able to graph, obviously. Are we clear on how to decide where to shade? Or do we need to review that as well? Pop that as well? Okay, so the kind of amateur hour is to just take points from all these regions and trial and error. That, to me, takes way too long, and is, at this level, you should be able to think through this. So, look here. For the parabola, you want y is greater than. That's what that symbol means, yeah? Don't think inside, outside, all right? Think y greater than the vertex. Here's the vertex, and I want y is greater than that. Do I want above the vertex or below that? Above. Greater than means above, yeah? So think above any point on the parabola means I'm going to go above the parabola. This is y less than. Y less than the line means small y's, that's got to be below the line. So I read these for above and below the figures. Above the parabola, below the line, that's got to be a message. You follow? If my life depended on it, I could take a point in here and verify. If I put in 1, negative 2, you would see it is true for both of those, and it does have to be true for both. You with me? All right, cool. 8 is the equation of a circle. I remind you it's just x minus the x of the center squared, and y minus the y of the center squared equals the radius squared. You could have squared over there instead of 16. Okay, the signs obviously do have to be right. It has to be x minus 2 and y plus 2. Are we cool? Okay. This, first thing I want you to check is, did you solve the square right? It's starting to frustrate me. When you dump a square, you say, well, what squared could have been 1? Well, it could have been positive or negative 1. So first of all, check that you, when you square rooted, it's plus or minus. If you didn't put plus or minus, there's no way you get this right. 1 or negative 1 then is at 90 and 270. This, 10. It's tempting to divide out a sign. Do not do that. We talked about how that loses solutions. Instead, you should first move over the sign, then factor out a greatest common factor of sign, and answer the two little questions you get. Either sine could be 0, or cosine could be 1/2. So would you call that 1 point? If you got to that point, then you earned a point. Then you have two little trig equations. Did you solve sine equals 0 correctly? That's 0 and 180. And did you solve cosine equal to 1/2? That's 60 and 300. Are you tracking? Okay. I don't remember what this question was. I didn't import these questions, but T10 number 19 is 1 over x plus 1. It was shifted up 1, obviously. T11 number 5 is 3 answers. X equal 4 for A, x equal negative 2 for B, and x equal 3 for C. Can I go? Okay. 3 more questions for T11 number 6. Each of these is 1 point. It didn't say degrees or radians, so for A, I'll take pi over 4 or 45 degrees. For B, I would take pi or 180 degrees. And for C, that's the harder ones. How are these going? These are a little more conceptual. Did you get 4/5? Did you get it right? Excellent. Okay, you use the inside, you work inside out. You first draw in the appropriate quadrant from the picture, from the inside, and then given that picture, you take the sign as opposite to hypotenuse. You had to find the opposite side by Pythagorean theorem or just 3, 4, 5 kind of knowledge. But that's where we're getting 4/5, and it's positive, not negative, correct? Sure is, Mr. Rickman. All right, the next one is 3. Yes? Last but not least. For the test 11, number 16, I'm feeling like the cosine was root 3 over 2. The tangent was negative root 3. Oh, it's minus a negative though, isn't it? Shoot. So that's minus a negative, so that's actually positive. So isn't it 3 root 3 over 2? Is that what you got? Got a mistake there, my bad. Okay. And so minus negative. And last but not least, y equals 7 cosine of x. Are we cool? Tell up how many you missed, how many minus ones on the paper, and move along. Then got the note paper we have. All righty. Okay. All right, okay. Boom, thank you. How you doing? All right, here we go. All right, go over there, kid. Good. Okay. So, let's go. I'm so anxious to see how we do together once the new stuff comes. Will you learn from me well? Will you not learn from me well? Will I teach you well? To be determined. This is still review. This, for the most part, you guys are good at these. My problem with this kind of problem on the notes, are we on the same page here? Okay. Is you're not showing appropriate work here. So this, I get people saying, oh, I know I need to drop the log base 8s off, right? And so you 8 it. Is that okay?
No.
No, that is not okay. What must you do? Combine first. After you combine, then can you 8 it? Yes. Can you do that in one step? No. That's the problem. Some of you are doing too much. Maybe you're just too darn smart for your own good. You're doing too much at once. I first want you to condense in one step, then exponentiate. So if you condense, this is the single log base 8 of what? 32 to the 4/5 over x plus 2 equals log base 8 of 2. Now, I have a single log equal to a single log. Now can I exponentiate? Yeah. Yes, now you can say, all right, and by the way, Mr. Rickman, I'm exponentiating this. Do you have to show that 8 to the? Yes, you do. At least if you want full credit, you have to show that. So, I get 32 to the 4/5. What is that? People, hey, it's perfect. You're in our class. This isn't your class. Excuse me. This one I was. That's my daughter. Okay. 32 to the 4/5. What is it? 16. How did you get that? Fifth root of 32 is? 2 to the 4th is 16. So we got 16 over x plus 2 equals 2. Oui, oui? Oui, oui. Then what? Let's get some participation. Maya, how you doing, kid? What did you do next? Good. I'm sorry, I didn't hear. I didn't actually listen to what I said. How are you? How are you? Oh, good. Okay, now what do I do? All right, beautiful. 16 is 2x plus 4. Kiana, what now? Subtract 4 from both sides. I don't know if you really need to show that level of algebra, but x is what, Devin? Devin, are you awake? Devin, are you in this class? What do you get? 6. Is that in the domain? Yeah. It is. All right, so x equals 6 is the solution. Are you with me? Okay, cool. Let's go on to another problem. This is gross. Are you ready for a gross one, Ellie? I didn't ask you before. Ellie? Oh, you're usually so positive. Oh, well. All right. So, the picture is optional. I tend to use a graph because it tends to check as I go if I'm on the right track. Here's y equals x minus 4. 2, 3, 1. Here's the point, 3, 1. And I'm trying to find the distance from that point to that line, okay? This is good preparation for a typical calculus problem. This is a big idea of calculus, minimizing distance. Now, you might say, well, shoot, there's a lot of different paths I could take from that point to the line. I could go this way, or this way, or this way, or this way. It's implied, or this way, it's implied that you're taking closest, quickest possible path to the line. Do you agree? What is the closest, quickest possible path? How does it geometrically relate? Straight. Okay, so straight. Isn't this straight? So it'll go me one better. Not just straight, but perpendicular. The quickest path is perpendicular to 1. So we really need to take the perpendicular path. All right. So it seems like if I'm going to find the distance from that point to that line, I need to find the perpendicular path. That's step 1. Find the perpendicular line. Once I have that perpendicular line, then what do I do? I want to find the distance from that point to that line. So I need to find where that perpendicular line intersects the original line. Then once I have that intersection, that really represents the closest possible point on the line. How can I then find the distance? Use the distance formula. This one here. Good try on the slope. That was a no. Sorry. But this, yeah? Now, if you're saying, oh, isn't there a formula? There is a formula. And if you can prove it to me, you can use it. But I don't think you can prove it to me.
Prove that thing?
No, not the formula. This? No, no notes. Close note. Prove this. Prove it. Prove it.
That is so much. I remember I learned that for the final.
Prove it.
No, I can do it. I know I can do it.
Okay. Good luck.
What was the first one?
It's going to be hard to prove if you don't actually know it. All right, so here we go. The perpendicular line. Let's go there. First of all, what is a point? The perpendicular line. What is a point on the perpendicular? What is a point our line goes through? 3, 1. Cool. What is the perpendicular slope? -1. If the original slope was +1, then the perpendicular slope is -1. Remember, it's opposite reciprocal. The reciprocal part isn't really showing up in this case, but it's there. Okay? Now, we have a point on our line. We have a slope on our line. Do you want to use slope-intercept or point-slope? Do you guys have any idea what I'm talking about when I say point-slope?
No, we learned the formula and that's it.
Well, forget that. You're using that here.
What is
So, all right. I am going to ask you to use point-slope form. And the reason is because I hope you all take calculus and use point slope form more than anything else in calculus. Point slope is this guy. And the reason I'm going to use it in this case is because the conditions I have. I have a point and I have a slope. So it makes sense to use point slope form. So y is, or y minus y1 is y minus 1 equals -1 minus 3. If I clean this up, isn't this y equals negative x? I get a plus 3, and then would I get a plus 1 when I move that one over, or what would I get after I moved everything to one side? Plus 4, plus 2, what do we got? Plus 4. Do you agree that you get a plus 3, you're going to add 1 over, so that's a plus 4? Are you with me, people? All right. Now, in terms of our grand plan, we found the perpendicular line. Does that seem reasonable with my picture, that the perpendicular line is -1 slope and the y-intercept is up at +4 territory? Okay. A picture will catch mistakes. You don't want to do all this mess if you got a mistake early. All right. Now I want to find where my line, y equals -x plus 4, intersects the original line. So now, the intersection point. Where does y equal -x plus 4 meet y equal x minus 4? Substitute or eliminate? Eliminate. Okay, so I get 2y equals 0. Y is 0, which means x is 4. Okay, they meet at 0, 4. Does that jive with my picture? Does that match? Yeah, that seems reasonable also. All right. Now, I just found the closest possible point on the line to our point. Finally, now I find the distance. The distance, by the distance formula, which is really just a form of the Pythagorean theorem, says the difference between the x's, 4 minus 3, that side of the triangle squared, plus the difference in the y's. Oops. I wrote this as 0, 4, but isn't it 4, 0? The difference in the y's is 1 minus 0 squared. So, at the end of the day, the distance is the square root of 1 plus 1, or the square root of 2. That's a gross one. There's one like that on the homework. I hope you took good notes. You can use this as a guide. All right? All right, 16. We did this the other day, but I think it could bear some repeating. So how do you factor a quadratic over complex numbers? You do. How do you do it? Solve by the quadratic formula. And then once you have the roots, it's just x minus each root. Try that on your own, and we'll compare in a second. All right. Mr. Massar, did you get 3 halves plus or minus 3, root 3i over 2? Okay, good. Kane, how do you then write it in factor form? Minus. Get this one first. So x minus 3 halves. And then, depending on which one you're doing first, it could be minus root 3 over 2i, yeah? And what's the second factor? Right. So in terms of the signs, make sure you have both 3 halves are negative, but the root 3 over 2i's, that's one positive, one negative, right? That's the answer. Are you done? Okay. All right. Rates and times and such. Vincent could do 2 jobs in 3 days. Jules could do 4 jobs in 7 days. Jules worked alone for 3 days before Vincent joined in. How long would they have to work together to complete? Sorry, that should be to complete a total of 8 jobs. Give me the big equation here. Hannah Sims, how would you relate all this stuff together? Wonderful. All right. Miss Tran, what's the rate of Vincent? 2 jobs in 3 days. I'm going to leave off the units. If you want to bring in the units, fine. What's the rate of Jules, Miss Livingood? 4 over 7. And what about a time relationship? We still have 2 times. Katie, what's the time relationship?
Time of Jules
Plus 3 equals rate of Vincent, or is 3 more than Vincent?
is.
So is, doesn't that read as
Yeah.
equals? And it's, for them to be equal, you need to add to Vincent's time?
Yes.
Because he worked longer, Jules worked longer, so for them to be equal, you need to. All right, cool. With that substitution fact, I would go in for time Jules, leaving me only time Vincent. Yay? Last but not least, let's do some algebra. 2/3 TV plus 12/7 plus 4/7 TV equals 8. This is where it's fun to watch you guys struggle with your arithmetic skills. It's you're a little rusty. We need to add the 2 T sub b's, yeah? What's the common denominator? 21. And so what is 2/3 with a common denominator of 21? 14 21st. And what is 4/7 with a common denominator of 21? 12 over 21. So what's 14 and 12? 26 over 21. 26 21st T sub v. And on the other side, we're going to need to take 8 minus 12/7. What is 8 minus 12/7? What's the common denominator? 7. What's... Okay, so 56 minus 12 is 44 over 7. 26 21st T sub v. So T sub v is 44/7 times 21 26. Does anything divide out? 7 divides out. Anything else? 2 divides out. Anything else? So T sub v is 66/13. So what are the units on T sub v or time? They are days. So a little more than 5 days. Okay. A lot of grossness. Besides the algebra, there's all the arithmetic in there. Be careful, be careful, be careful. All right. 18. We talked about this last week. For downwind, the idea is distance down is plane plus air or wind or plane minus wind. If you're going downwind, are you going with the wind or against it? With. And so does that wind help you? Yes. And so is it an addition or subtraction? Addition. Downwind is plane and wind together times downwind. And upwind is plane take away the wind that's fighting against you. All right. Then it's figuring out what all to put in. So what about the helicopter could fly at 4 times the speed of the wind? That means plane is Guess it could have been helicopter, my bad, but you get the idea. Plane is 4 times the wind, yeah? So I can put that in. 600 miles downwind, 1 hour. I'll put the distances in. There's not a lot of thinking to do there. What about the time? What do you make out of that time? Time D. It can fly downwind in only 1 hour more than it took upwind. TD is 1 plus TU. All right. Now, if we throw those two in with the distances, let's see where we stand here. Let's, first of all, 600 is a downwind distance. How does the P plus W come out? 5W. And do I plug in for T sub D or leave it T sub D? Sub it. Are you okay with the substitution stuff? Is it too much at once or are we cool? Okay. What about the other? What's the distance upwind? 300. When I substitute in, the plane is 4 times the wind into the upwind equation. 4 wind minus the wind is 3 wind. And do I plug anything for time up or do I leave it time up? Leave it time up. All right. Now here's definitely where we could do this smarter and save ourselves some work. What would you do now? WT. Okay, so here I can say the WTU is 100. Right?
Yeah.
All right. What do I need to do to that first equation before I can use that fact? I don't have a WTU here yet, right? So if I multiply this out, I get 600 equals 5WT sub U plus 5W. All right, now can I use that 100? All right, so if I throw that in, I get 600 equals 500 plus 5 wind. From that, you can probably see that the wind is 20. Last but not least, make sure you answer the question with units. What was the speed of the helicopter in still air? The helicopter is like P. What is the helicopter? 4 times 20, so it is 80 units. All right. Hardest part of this is figuring out how to structure it well so it flows. And if I look back on this, I don't know if it flows. I got the answer. I don't know if it's clear. You with me? Okay, work on that. All right, last but not least, domain and range from a graph. Domain, when you think domain, you think left to right. Let's do these in interval notation. And then parentheses or brackets, all right? So for this first graph, what's the leftmost point? -4. And do you actually touch or have -4?
No.
So do I use a parenthesis or a bracket? Parenthesis. All right. What's the rightmost point, Jude? 6. And does it actually touch that point? Yes. So do I use a parenthesis or a bracket? Bracket when you actually want to include the point. All right, so that's the domain. If you throw a D next to that so I know which is which. And the range, when you talk range, range is low to high. Low first to the highest point on the second. So what's the lowest point on the graph? Who haven't I heard from? Spires?
-4.
-4. China, what's the highest point on the graph? Say it again. +4, yes. Does it actually touch those points? Eric, do I use parentheses or brackets? Brackets on both. True. All right, good deal. Do the last one, please, on your own. Make sure you've got it. And notice the arrow there. That's important. It is at an angle. I believe. What does it look like? It's going sideways, isn't it? Yeah, assume it's going sideways. It's passing the vertical coordinates. All right. So, speaking of that, Colin, what's the left edge of your graph? And Ryan, what's the right edge of your graph? 4. Miss Morrow, parentheses or brackets on that? Parentheses on both? And on 4 bracket? Okay. Cool. Who else haven't I heard? Gigi, what's the lowest point? And the highest point, Brianna? 4. And inclusive of negative infinity? No. And what about 4?
Yes.
Okay, cool. All right. That is that. Homework real quick. You have about 12 minutes. So it's tempting to say, oh, 12 minutes. That's so little time. Let me just play on my phone. But that would be basically saying I'm a total weasel, Mr. Ratner. You don't want that. So instead, write down some problems. Am I right, Gigi? This is no weasel time. Don't be a weasel this weekend. I'll try not to be hard contact with you. No weasels, no. Weasels are terrible, terrible animals. Don't be vermin animals.
I actually started
Weasels?
I've been calling people weasels.
Isn't it great? It's so useful. It's not mean, but it's also negative.
It makes people feel terrible.
Think so?
Would you want to be called a weasel?
If I was a weasel, I would want someone to tell me to call me out, right? If I were you, I'd focus on the hardest ones. Maybe get that distance from a point to a line one knocked out, so at least you don't have that hanging over your head.